Hi, my name is Zico and I'm a technical specialist at Pico Technology. In this PicoLog 6 video, we'll be going through custom scaling and channel maths. To demonstrate custom scaling, we'll be using the PicoLog 1216 data logger. This is part of the PicoLog 1000 series of data loggers, which is a low-cost, high-speed, multi-channel data logger that can take up to 16 channels, up to 12 bits resolution, and can measure 0 to 2.5 volts. So to demonstrate custom scaling, we'll be using the power supply and we'll be feeding in a 8 volt signal into the actual PicoLog 1000, which is higher than its input range, but we'll be using this terminal board over here, and we've got a couple of resistors in there that are dividing the voltage by 4. And we've got a couple of cables here going into channel 10, which is where the potential divider is happening. So actually plug the PicoLog 1000 terminal board into it, plug the unit in, and I'll feed in the crocodile clips there. So as you can see, the PicoLog 1000 unit appears on the screen. So what we'll do is now add the actual channel, and it's on channel 10. We select channel 10 and then click on add channel. So we'll increase the voltage to say approximately 8 volts. And as you can see on the screen, we're getting 2 volts. So the actual physical potential divisor is doing its work. So now what we need to do is do some custom scaling. So if I go back to channel 10 and click on it, go to advanced options, select custom scaling. There's 2 types of scaling. There's equation and table. We'll start off with equation. So go input multiplied by 4, and the return units will leave as is because it's still measuring voltage, but you can vary the return units if you require. And click on save changes. And as you can see, the voltage has changed accordingly. The next type of scaling is the table. So if we go back into the actual channel and then select channel 10 again, and then we can now change custom scaling to be from equation to table. Now in this case, you need at least 2 pairs, so we'll do raw space scaled. So we'll start off with the minimum, which is 0, space 0, so the raw is 0 volts and the scaled is 0 volts, and the maximum would be 2.5 volts, and what we want to scale it up to is just 10 volts. So 2.5 space 10. We'll leave the units as is and then click on save changes. And as you can see, it still remains scaled correctly. To demonstrate mass channels, we'll be using the USB Dr. DAC, which is a low-cost, multi-channel data logger, oscilloscope, and signal generator. It has standard inputs, which include a scope input, digital inputs, and resistance inputs. It also has a number of built-in sensors, which include temperature, light, sound level, and sound waveforms. We also have a number of dedicated inputs, which are a pH/redox input. And we have 3 external inputs where we can plug in either a temperature sensor, humidity sensor, or an oxygen sensor. We also have outputs, so we have a signal generator, and the digital inputs can also be used as digital outputs. So in this video, we'll be using the DD100 temperature sensor and the DD101 humidity sensor to calculate dew point. So dew point is the temperature at which air is saturated with water vapor. If the temperature drops below dew point, water will condense on solid surfaces. So we'll be using input 1 with the DD100 temperature sensor, and input 2 with the DD101 humidity sensor. We can now plug in the unit into the USB port, and as you can see, the unit appears in the software. So we'll click on the icon or image of the Dr. DAC, and on external input 1 we will select that, and as you can see, temperature automatically is detected, and we will call that temp. an external input 2, we'll click on that as well. And we'll call that relative humidity, we'll call it RH for short. And as you can see, we have the temperature and humidity appearing, and we can now add our third channel, which is the dew point channel. So if I click on the screen to minimize the image of the Dr. DAC, you can see the calculator there, which is where we input our math channels. So if I click on the calculator over there to enable math channels, we'll call this dew point, and we'll input the formula for dew points, which is and we'll change the units to be temperature and make sure it's on Celsius because this formula only works for Celsius, and click on add channel. And now we've got third channel giving us the dew point. So I'll start by capturing some data, and I'll go to the chart view. You can now see 3 separate readings on one graph. 2 of them are temperature and 1 of them is a percentage. So we can drag the RH one, which is in a percentage form, down, and you can see there it goes to a second axis. You can actually have up to 4 axes. This concludes this video on custom scaling and channel maths.